Hi, everybody, and welcome back to the Mental Toughness and Body Show. Today, I am joined by Dr. Jeff Gross, founder of ReCELLebrate, a world leader in regenerative medicine. And after decades as a neurosurgeon, Dr. Gross is now pioneering breakthrough therapies using activated NK cell-derived exosomes. I know I pronounced that right, Jeff. Tiny messengers with massive potential. We're talking here about cancer treatment without chemo, immune system upgrades, and the science behind destroying the zombie cells that accelerate aging and disease. This is such an exciting area. And this conversation could really redefine how you think about healing and performance. Dr. Gross, welcome to the show.
It's my pleasure. Nice to meet everyone, and thank you for having me, Rob.
So let's get straight into the fact that you've had a shift from neurosurgery to regenerative medicine. I don't know whether that's a logical shift or it's a passion. I mean, I started out as a chartered accountant, and now I work in the space of really health, wellness, fitness mindset because I believed I could have a greater impact on humanity. So maybe that's similar to yourself.
Yeah, very much. I mean, it multiple, data points went into, this shift, and some of it was by desire, and some of it was accidental. But in short, I was treating a great number of patients. As a neurosurgeon, my focus was in the area of the spine, so neck and back pain, uh, or what you folks like to call dodgy backs, I understand, and
That's right. Yeah.
uh, disc problems, pinched nerve problems, things like this. And my patients would come to me and we would try all kinds of very conservative things. And sometimes those wouldn't work. And then they'd come to me and say, okay, well, what's next? And I said, well, the only thing left on the menu is surgery. And they go, surgery? I'm not ready for surgery. Great, because I didn't want to offer you surgery anyway.
Yeah.
Well, what else you got, doc? In that doctor's bag you carry around. And some of them would say, well, how about stem cells? We hear about stem cells all the time.
Mm.
And luckily, chance favors the prepared mind. And I had done some undergraduate work in that area long ago. So I said, you know what? I'm going to look back into that. And I decided to, put down the usual textbooks and go re-educate, relearn, update myself in an effort to add regenerative medicine, stem cell based biological, that's important, things into my offerings, my options for people. And that has blossomed into so much more. And it's really all I do now.
It's interesting because when I read about like NK cell derived, is it exosomes? Is that how you pronounce it?
Yeah, you got it
Yeah.
right. Yeah.
And so I'm thinking, what the hell is that? And the first thing I thought about before going on a bit of a deep dive was stem cells. And I'm like, is this
Yeah.
stem cells? And then I've got a sort of a left brain analytical side, and I wanted to go a little bit deeper and say, okay, are these extracted? You can educate me here. Are these extracted from stem cells? And it said no, but it's extracted from the blood from a healthy person, and they do all kinds of sorts of fancy things to extract the exosomes from there. So it was kind of explained like the exosomes are the work or the packages that get sent out from the factory. Is that,
That's right.
yeah.
That's right. It's a bit more broad. You're on the right path. There are many ways. In a general sense, Rob, all cells in our body make signaling packets of information for other cells in the neighborhood and some far away to read. And it's one way from some cells to influence other cells. Not unlike a community where one person influences other people by what that person says or how that person dresses or the
Mm.
mindset of that person. So this information is a packet of information one cell gives off. It's very small. And I know that sounds silly because cells themselves are small, but these little out bubblings of a cell that are given off are called extracellular vesicles, and for short, exosomes. Exosomes mean a body out of. So these small bodies that come out of cells. So they're even smaller, about 1/1000th the size of a cell. And each cell can make lots of them. But when we talk about exosomes in a therapeutic sense, we're talking about really stem cell derived exosomes because I don't want to give someone a bunch of old, cranky, inflamed, aged exosomes, right? So the best source of the stem cell derived exosomes comes from amniotic fluid in healthy, screened uh, mothers who donate their amniotic fluid at the time of a successful C-section of a healthy baby. So
Okay.
it's very ethical, and it's a regulated process, at least here in the States, and how that's done. And then this amniotic fluid is basically filtered. They get all the cells out of it. They get all the large proteins we don't want out of it, and it just has small growth factors in these exosomes. And it turns out that is a stem cell signal.
Okay.
And
And
the
so,
natural killer cells is a little bit more complex, and maybe we'll get into that. But I wanted to give the broad
yeah,
overview.
which is what NK stands for, right?
NK is natural killer cells. So this is a subset of cells in our bloodstream, particularly the white blood cells. So it's probably 1 or 2% of our white blood cells. And the white blood cells may only be 10% of our blood cells. So you're looking at a very small proportion of your cells. These are amazing types of cells, these NK cells. They serve to remove abnormal cells out of our system, like infected cells, like accidental cancer cells that we all make
Mm,
from time to time, and they need to get edited out. And also something called senescent cells, these cells that sort of have divided many times, they're kind of aged, they're boggy, they're full of junk, and they're no longer contributing to the community, but they're taking up resources.
yeah.
So they tend to, take up space, and the more of them you have, the more senescent your biology is, the more aged or inflamed your biology is. So if you can remove these, then you have a younger cell population in general, and you yourself
Yeah.
can be effectively biologically younger. So NK cells selectively, without hurting our normal cells, remove these, and they do so by delivering, guess what? Natural killer cell exosomes. The exosomes are business end of cells. They do the work.
So this type of treatment, like I hadn't heard of it before, but also I don't work in the space, so no surprise there. But I like stem cells. I mean, I don't know where that. I can remember first hearing about that. There are a lot of ethical concerns and so forth here in Australia. From what I understand, it's fairly widely used now, and no one's talking about it. So somewhere along the line they've accepted it. How I did some research to see like who are producing these cells here in Australia, and there's no one producing them in Australia at the moment. But I believe that there's some like labs associated with unis or something that they're going down that pathway. But it seems like the
Right.
US and Europe are the only people that are producing this at the moment. So just in terms of time frame, how new is this and how widely being accepted is it? I've seen that like you've got thousands of papers that and peer reviews of all your work that have been done. I mean, like it's so commendable on the work that you're doing, but just to help people get a picture of how groundbreaking it is, how new it is, and where we think it's going.
Well, I mean, this isn't new. In fact, we in the States are just adopting it over the last few years. I think Australia's a little slower than we are at the moment. But the work in Europe and in Asia has been ongoing for over 20 years in a clinical sense, meaning actually delivering these to patients. In fact, our famous professional athletes here in the US for 20 years have been going to Europe to get treatments, big name, athletes and famous people. So there are a lot of people from the States who go to Central America to get these because it's a little looser down there. You can get these things, but you're not far from, China and Korea, where a lot of this work has been done, and there are available places to treat. So if you're so inclined, you get on a plane and you
Off you go.
escape some of the over regulations you may have there for a minute.
Yeah, okay. And so in the work that you're doing, do you have a specific um I suppose illness, whether it's cancer or whether it's aging, immune like autoimmune disease or anything like that? And I suppose that's the first part, and I suppose two-prong. And then is it a case of it? I don't know whether it's going to come out the right way, so I mean in the most respectful way, but is each person, it's kind of a little bit experimental because we don't exactly know. We know the theory that it's,
Yeah.
that they're going to kill the bad cells or whatever, but do we know whether the exact impact that it's going to have?
Yeah. Let me address those in reverse. I'll start with the second question. So, as a doctor who's treated thousands of patients, we only want to do the best for that patient. We stand
Mm,
behind the Hippocratic Oath. Everything we do is based on some good published science somewhere. It may not be American science, it may not be Australian science, it may be, French, it may be Chinese, but we're not shooting from the hip. So anything I do is from a list of options for someone, and those options may include something more traditional,
mm,
surgery, chemotherapy, something else. But I would be wrong and not protective of my patient and not giving a fully informed consent process if I didn't offer these things. At least
yeah,
talk about them. So we offer them. And then you said, is this experimental? Well, how do you define that? Everything is experimental. If you had high blood pressure, Rob, and I gave you a pill for high blood pressure,
yeah,
uh, it's an experiment to see if that works for you without hurting you.
yeah,
So I've never guaranteed anything. We go over the risks and benefits. So I think the word experimental is too vague and ambiguous to consider. So yes, everything is experimental. Crossing the street with cars going through it is experimental, right? So, so to some extent, yes, there's some less science in stem cell because it's newer, but sometimes newer things are the best things. So
yeah,
we don't want to throw it away. As to your earlier question, what disease processes, what is this? Well, when we speak to the more generic stem cell derived exosomes, my low hanging fruit is osteoarthritis, bone on bone, joint problems, dodgy backs. We're looking at spine and joint problems. They respond generally well. We get
okay,
some really good results without surgery, mind you. So this is instead of a knee replacement or something. We also use them intravenous for inflammatory issues and autoimmune problems, certain infections like COVID and Lyme's disease, things like that. And even some of the diseases of aging are the diseases of inflammation. As to
right,
the natural killer cell exosomes, this I sought out. These were difficult to get. I sought them out because, like any doctor, the most noble thing you can do is relieve suffering and pain and help people
mm,
with cancer. So I wanted to have an option for people with cancer. So we got these, and the goal, if you follow the research on this, because it's out there, is to help shrink tumors, right? Help
right.
prevent spread or metastasis, help prolong remissions. That's what we're trying to use them for, and it's cutting edge.
And the how far? Oh, well, no, let's go back to the like the joint issues to start with. What I can imagine that reducing inflammation is a major thing. But if you've got like bone on bone and things like that, as like anything, there are some limitations. But you said like in terms of preventing a knee replacement and things like that, how far can they go beyond reducing inflammation?
Well, we have examples. I'm not allowed to make, wide claims, but we have
Yeah, yeah,
examples with MRIs before the treatment and after a year after the treatment where we've shown worn cartilage that's thickened back up. So
yeah.
it
Wow.
is possible to regenerate your own cartilage. We just help it happen.
And so then when we go to cancer, is there a stage where I don't know, is it stage four? Is that the last
Yeah,
stage? If it's at
typically.
that
Yeah.
stage, it's like there's just no point. But if it's stage one, two, I don't know, I'm just making stuff up. But is there?
No, listen, if you're in stage four, this is your last chance to try anything, right?
Mm,
Even something you might consider experimental. So we have addressed stage four. We've had some move the needle in the right direction for some of these people, and we're actively treating them. So this is a relatively new additional tool for our practice. We've only had these for less than a year, but we are
right.
making them available for people to try. And so far, we've had some great results. Not enough to make any claims. We're going to gather all these and publish them. But if you look at some of the references in the literature, in the medical literature, they're amazing. It's almost like you couldn't find a better natural, non-toxic, side effect free,
Mm.
off the shelf cancer, you know, cell killing biologic.
And are they like, is it an infusion or an injection or something like that? Is that how it goes into the body?
Both. Yeah, both. So you can have an IV to, police the circulating cells that might be lurking and trying to set up a tumor somewhere. And then we also have success injecting actual masses when we can reach them. So
Okay.
that's injection based. Yeah.
And is it a once off? Is it a like an ongoing treatment? Or?
Well, we everyone's an individual, so we treat once and then we observe and do tests. We track markers, we track scans, and if it's if it's moving in the right direction, we watch it move in that direction. If it stalls, then we might consider a repeat treatment, give it another goose, if you will, another
Yeah,
boost
yeah.
of fuel. Yeah.
You said earlier about being collected from the embryonic fluid. Is that ambiotic fluid from mums after a C-section.
Yeah.
Um, I like to use AI a bit for doing some research, and it suggested that these cells could also come from like very healthy, say,
Yep.
athletes.
Yeah.
Um,
Healthy people can donate. It's a little more laborious to derive new sources. So the sources we have now, and they're very difficult to collect just by sheer numbers, are usually from a population of stem cells. And the stem cells are separated until they find the very, very few of them that are natural killer. They were destined to become natural killer cells. And from there, they grow those and let them divide in a culture setting or a flask. And then they ask those cells to produce their message, their exosomes, and then they collect that separately or separate it from the cells. And then, so that's typically the process, a little more involved, but generally the process. You could do that from healthy donors. You could do it. This will become more widespread, and there will be multiple avenues of sort of collecting these things.
is it a case that it's only now that the more research and evidence-based work that's being done that people are seeing that, wow, actually this needs to be bigger? And you said they've been doing it
It's
for 20 years in some
it's
countries, but
Yeah, it's quietly been there. But yeah, when does it reach critical mass where enough people rise up and say, we want this, And honestly, here in the US, it's usually when some big pharmaceutical company
yeah.
decides to put a lot of money behind it, and then the government gets behind it with funding because of the lobbies, they're driven to put that money behind it. So like anything, it requires the right funded research.
And are you the like main driving force behind this in the US? Is that why? No.
No, I'm a simple country regenerative stem cell doctor. I really am here to just make this available to individuals. I want to treat patients. I'm not here to make an elephant turn around on a dime in the US. But I'll happily do what I can at my level to provide the right impetus and data and clinical stories and results to support that.
Yeah, okay. The you talk about zombie cells, which just sounds
Yep.
we need to have a movie about it. But what tell us about what they are and how I suppose dangerous they are when it comes to whether it's the aging and diseases.
Well, look, what is aging? Aging is really a collection of this chronic inflammatory cell damage, cell degeneration. And when your cells are busy fighting its environment from all these things that cause inflammation, like stress, poor diet, poor nutrition, poor sleep, all these things, the cells can't do what they were made to do at their best, at their optimal with cellular toughness, if I can tap into the name of your show a little bit. And if you think about it, if you could let them be their best, then the body's essentially functioning in a more youthful, optimal state. So you wouldn't be as aging as fast. And aging can be a number, how old are you? And it can also be a physiological or biological status. How old do your cells behave, right? Because you've probably seen two different 70-year-olds. One is youthful, plays
Yeah,
tennis, looks great,
exactly.
has a great attitude, and one is in a wheelchair at a nursing home. We call them here, old folks
Yeah,
home.
yeah,
So the difference, is the one of the differences is senescent cells. So if you accumulate senescent cells, you're accumulating these damaged, broken down, junked cars, in your garage, and you can't get your new car in there because all this junk stuff is blocking the way. So the more you clear out and remove, recycle these bad cells, the more youthful as a percentage your cells are. So let's say you have, 1 trillion cells and 10% of them are senescent. Well, gosh, if you can get rid of half of those, then you just have significant benefit in reducing the population of these aged cells. So natural killer cells help us do that by their exosomes. So there's some really great work. Now, this is before the exosomes were collectible. They just used natural killer cells, but they took natural killer cells in a cell culture. They gave them back to patients, and then they measured age markers. And for example, there's an enzyme in the blood you can measure that speaks to how many of these zombie cells you have crawling around. It's called beta galactosidase. And they showed when you give more natural killer cells and you improve the body's ability to remove these crazy things, then you have a reduction in that age-related marker for up to 2 years. So you can imagine, well, a strategy where you reapply natural killer cell function to strengthen the immune system to fight cancer from the inside out.
yeah. Well, it's so exciting. The Do you think the potential for this? I mean, does it take a big pharma to come along and say, "Hey, we're going to put our money behind this because we can see a potential"? If I put my entrepreneur hat on, I could see somebody like if I look at what has happened here in Australia, probably the biggest change in marketing that I've seen here in the last 5 years is all around collagen, right?
Yep.
And the marketing for anti-aging collagen, everything's got collagen in it. It won't be long before your cornflakes has got collagen in it. They've got protein in it now, so it'll be collagen next.
Right.
Is the anti-aging side of this going to be what it takes for like a big pharma to get behind it? Um, and then they see that, okay, there's some other benefits here.
I actually think the anti-tumor, anti-cancer side of it is more marketable or
Okay.
monetizable for a big pharma company. The anti-aging side, although growing, I agree with you, it would be a side benefit from that. Yeah.
And is there momentum from them to get behind it? Say, oh yeah, look, once you get to, like 10,000 cases or whatever, then we'll jump on board. Or
No, there is. You see, at least here, a lot of pharmacy or big pharmaceutical companies are getting involved as small investors to projects in the biological space, stem cell based, things like this. They're they want their finger in it in case it takes off amazingly,
yeah.
and they want to figure out a way to monetize it. Sadly, they've coaxed the government to classify cells and exosomes as drugs.
Oh,
Yeah, so we're just basically walking
right.
around drug factory and made of drugs, which makes no sense, right? So they've
Yeah.
widened the definition of drug to fit their ability to monetize. So actually, that's a little distasteful, but we
Yeah.
have to behave and follow those definitions. The thought police are very strong here.
Yeah. Yeah. And like from a personal and professional perspective from you, what's the biggest challenge for you right now in this space?
I would say getting access to these types of things and at a high quality where we can vet the lab where they're made or derived and the quality testing, the third party testing to make sure we have high quality, high potency material. It's exactly what we want when we're going to be giving it to someone. So that's probably one of the challenges, and there are more and more competitors in the space, and there are some great ones and some not so great ones.
So supply, is that the like an
Yeah.
issue for you? You've got a list of, so many patients, but there's only so much supply to give it. So you
Right.
have to work out, okay, let's give it to the ones where we think we're going to get the biggest bang for our buck first.
For the natural killer cell side of things, that's true. For the more generic stem cell derived amniotic sourced exosomes, no, we luckily amniotic fluid is produced every day by many mothers delivering. So that there's enough of that going around. And I use more of that than anything. I do a lot of joint and spine work and wellness and other things. So we save the natural killer cell exosomes for those that are truly in need, the cancer patients.
So we're using the mums because that's it. They're having a procedure anyway, so it's just kind of a next step kind of thing. Is that how that
Well, it's a
translates?
highly inexpensive source. These mothers are not compensated. The ethical donation process in the United States mandates no payment. So if you donate an organ or you donate blood or something, you're not to be paid. Otherwise, then you start to get this conflict of interest. People are,
Yeah,
donating all their blood until they're ill, you know. So it's a free source. I mean, there's some costs related to the collection and the delivery and the lab and the testing and all that. I mean, I do pay for these things, but
yes,
it keeps a lid on the cost of these things. But the source is there.
yeah, got you. How much these days do you believe that the lifestyle of people, certainly in the aging process and the like, just I mean, the food that they're eating, their activities, and so forth.
Yeah,
What I see in the clients that I coach, it
yeah,
dramatically increases their age. I mean, I'm not sure
yeah.
how old you are, but given all your experience, I'm sure you're much older than you look. And the same
Oh,
with me,
thank
like I'm
you.
about to turn 57, and people say, "Wow, you don't look like you're 57." I said, "Well, I don't drink, I don't, smoke, take drugs. I have a very healthy lifestyle. It's very regimented. I eat very well, and that's got to have an impact on the whole anti-aging process. I do strength
Yeah,
training, cardio, all that kind of stuff. Do
yeah.
you see that we are actually getting worse? So there's a more of a need for these NK zones because people's lifestyles are just getting worse, and also I've got a cancer question for you as a follow-up, but the the volume of illnesses and diseases that people are getting is just becoming more widespread due to lifestyle.
Absolutely agree with that. I think lifestyle, what we call lifestyle medicine or epigenetics, is the more significant component and contributor to your health span, your longevity, your inflammation burden, how old you feel, how old you look, how old you are physiologically. Without a doubt. I think, it used to be years ago if you had like if you were obese and you would say, oh, it's genetic. My mom was obese or something,
Yeah.
and now we look at things and find out that's absolutely wrong. Our genetic diversity in our cells, in all these genes and all these chromosomes, is incredibly adaptable. We would not have survived millions of years as Homo sapiens or what the predecessor species if we were not adaptable. And we know that too, because you can take someone who's completely out of shape, transform them in a year into someone who's a completely different body and
Yeah.
mind, and we are adaptable. And that means lifestyle. So it's choices, nurture over nature, although some of the choices affect your nature. It's choices. I agree.
I have a client that's a nurse, and I guess they get access to some information before it becomes widely known in the public. And they're saying what they're seeing here in hospitals here, which has come from stuff overseas as well, but they're now seeing the highest rate of cancer in like late 20s, early 30 year
Yep.
olds,
Yep.
that the only thing that it's attributable to is lifestyle. And for the first time ever, that they're starting to see that. And that's
Oh
like
yeah.
so troubling.
We're seeing some of that here too. There's a concern that it may have some relation to the COVID pandemic and or the attempted vaccination thereof.
Mm,
So we're going to learn more about this in the coming years. We are seeing not only cancer, but other inflammatory burdenous problems in the younger population, declining hormone, both male and women early. We're seeing, mental health problems, earlier dementias, earlier cardiovascular problems. There's something that's accumulating at a faster rate, and it's not a good thing.
do you think we will get to the stage? So it's winter here in Australia. Melbourne gets quite cold. So I have a flu shot to protect me from the number of clients and so forth I see. Is this technology um, getting to the stage where like someone like you and me are still going to benefit from having a shot, if you like, of healthy NK cells in the future? I know we're obviously a long way off that because of supply and
Yeah.
everything, but is
Yeah.
is that a situation where you and I would both benefit?
I think so, and there are going to be different ways to do it. It may not just be the NK cells or the exosomes. There are other ways we can boost our own natural killer cell activity. You can take glutathione supplements. You can take, there's certain phytonutrients, plant, fruit, and vegetables that help support that.
Mm,
Um, there are different things you can fast. You can do high intensity exercise. You can do hot sauna, cold plunges, anything falling under the hormesis umbrella where you give your body a slight stress to build resilience. A lot of those things will boost your NK cell activity to prevent cancer. So what we need to do, and that falls into the lifestyle side of things that you brought up a
yes,
moment ago, right?
yes,
So, there will be other ways, gene therapies, or ways to stimulate the NK cell population. We can stimulate red cells, we can stimulate white cells. Why not NK cells? We just don't have that stimulant yet. So, at least in a pharmaceutical form. So, we will learn more about this. It's going to be a wonderful thing, and it may replace the flu shot. Because getting the
yeah,
flu and being natural about it is probably a better way to go, unless you're completely frail or at high risk of some type of problem. The vaccines are not without complication. The viruses are not without complication. And this is about, weighing the risks and benefits of both. And this is very controversial because, we jumped to a COVID vaccine without
yeah,
long-term testing, in part because we had to, and now we're seeing some problems.
yeah, yeah. Autoimmune disease, is this something that this therapy works with as well?
Yeah, because autoimmune disease is a hyperinflammation out of proportion
Yeah,
for what it should be. Anything in the regenerative biologic space, stem cells, stem cell-derived exosomes, tend to be highly anti-inflammatory, and they can help suppress the inflammatory damage, the flare-ups of these things. So we've seen them useful in all kinds of, MS. We've seen it useful in rheumatoid arthritis, thyroiditis, irritable, inflammatory bowel syndromes, leaky bowel, the whole gambit of hyperinflamed problems. These approaches, these biologics tend to quell those, and even the blood test markers of inflammation.
so going back to where I started with you being in neurosurgery, how exciting is the work that you're doing now compared to the neurosurgery?
Well, I think it's a reinvigoration for me.
Yeah,
Neurosurgery was exciting and glamorous, and taking care of trauma and clipping aneurysms and doing all you know, the things that you might see on a television drama were real. But you do them for a few decades, and there's a lot of stress and difficulty involved in particularly our system here in the States, which has absolutely crushed the quality of healthcare in that realm. So it's another reason why I was happy to sort of transition into this more practical side of medicine where I can really do more good for people without, having a happy patient, happy doctor in a positive system. Whereas the other system's so broken because all the money in healthcare in America is sucked out in the middle by the insurers.
right. So it might be ironic, but 78% of my listeners are actually based in the US. Um,
Wow.
and
Yeah.
not in my own country. But if there are people here in Australia and they want to work with you, or the people in the US, how do you? Well, firstly, in Australia, can we travel to you said about China or Korea or Asia or somewhere, but can people here in Australia travel to the US for this type of
Yeah.
treatment?
Oh, yeah. Yeah, I mean, I've spoken with Australians and people from other countries. We do a lot of our work initially remotely by video,
Okay,
just like we're talking now. You know, if they need tests, we can get them probably in their home area, and then we can review the tests remotely. And then we only invite people here to our Las Vegas clinic if there's a reason to invite them here. You
right.
know, so so yeah, I mean, we see most of my patients actually are not from Las Vegas these days.
Okay, okay, terrific. And so if people want to get in touch, I'll put the link below here, but you've got a website. That's the best way
Yes.
to get in touch with you.
Yes. Yes, so our we rebranded our practice. It's called ReCELLebrate because we are celebrating the renewal of our cells, and that is spelled ReCELLebrate, and that's our website, recelebrate.com. It's our Facebook, our LinkedIn, our Instagram, our whatever social media platform. We probably have a ReCELLebrate, you know, flag planted there. So, and as far as I know, we're the only people using that word. So you should find us relatively easily.
Yeah, yeah, I like it. What, just a couple more questions. What would you say that you would like to be remembered for? What would you like your legacy to be?
I would like to be remembered by patients for listening to them and providing them options and helping make them live better longer.
Yeah, yeah, nice. Actually, that's just made me now think about another side of things. What impact, if any, does this have on, I'm going to say mental health, so like brain cells and that kind of stuff? Is there any evidence to indicate that there's a change there?
There's some literature suggesting benefits in, we'll call it stem cell biology towards mental health. I haven't dabbled in that area particularly, but we do help neurological problems of the brain. You know, you look at Alzheimer's disease, which is growing here in the US. There's an inflammatory component to that. So if we can help suppress the inflammatory component, we may slow the disease. Same with multiple sclerosis, MS. It's an autoimmune inflammatory issue. Recovering from brain injury, there tends to be some benefits when we use the stem cell derived exosomes to treat those patients. So another beautiful thing, Rob, about exosomes is they're so incredibly small, they will cross if you put them in the vein, they'll cross through the blood-brain barrier and get into the brain. Stem cells are really too large to do that.
Right. Yeah. Yeah. I'm wondering about things like depression and things like
Yeah.
that. If there are these zombie cells that are running around, essentially saying, "Hey, be sad, be sad, be sad," and we kill some of those off.
It's a great question. I haven't done we'll call it a deep dive on that topic because I just don't tend to see those patients seeking that. But I've read in passing through some literature that there are mental health and stem cell biology. There is some overlap there. I just don't know enough to make a reasonable comment for you or your audience at this time.
Yeah, yeah, sure. I think, look, the bottom line from what I see in the work that I do and the more and more work that comes out, like if I use Ozempic as an example here, which is bigger in the States, it's now becoming bigger and bigger here.
Yeah.
I think unfortunately people continue to look for, to me, it's a bit like winning the lottery. It's like, no, go out and do it the hard way, the slower way to, get the joy of earning the money. And it's like the same with people are looking for a pill, an injection or something to get that quick fix, but that just leads to another problem. And so I think there's a whole combination of people just being more focused on their healthy lifestyles and from a mindset right down through to the training that they do and the recovery, like you said, with the hot saunas and the plunge pools and all of that kind of stuff to um, help people live a healthier life. And then your therapy comes along and just really provides the cherry on top and the icing of a solid cake you've already built, right?
Largely, I'm a big fan, however, of we'll call it the GLP-1 family or the GLP family, the Ozempic. When you get older, your metabolism's not the same. I have people that work out and exercise and they can't lose weight. Your insulin sensitivity changes,
Mm.
and sometimes you take these old stick shift cars, you have to give them a push to get them pop started. So I like the GLP-1s for that. We also use them for things outside of weight loss, metabolic improvement, insulin sensitivity, reducing inflammatory burden. We're now seeing in the longer longitudinal studies reduced risk of cancer, cardiovascular disease, dementia for people on these meds. So there's more to it than just weight loss. In fact, we have a
Yeah.
lot of people now that we call it microdosing. They're just on a very low dose. They're not taking it to lose weight. They're taking it because something in our environment or our food chain has crushed our insulin sensitivity, and this helps us hack it back into place a bit.
Yeah. Yeah. Well, Jeff, I mean, we could keep talking for hours here. This is so interesting. Um, I don't know whether you wanted to add anything further to what we've had. I've got one. I'm going to give you the closing word, but have you got anything else you'd like to add before we finish off?
Well, we talked offline that I've become sort of de facto exosome expert here in the U.S. and beyond, and in my studies I found that the exosomes not only come from the human or an animal, uh, they come from other sources. You can get exosomes from milk and colostrum, which is early milk. You can get
Hmm.
exosomes from bone marrow, which you can eat. It's a dish. Many animals eat it. You can get it from bone broth, which, as you know, has health benefits, and you can get it from plants. And so I was stumbled upon this a few years ago, and I'm digging, and I found out that if you look at phytonutrients, and that's a code word for the little supplements and nutrients you get from fruits and vegetables. Um, Many of them are come from the plant encapsulated in a plant-derived exosome. So these plant-derived exosomes have far-reaching health benefits. In fact, there are many more references than there are on plant exosomes than on human exosomes.
Yeah,
So
wow.
I contracted with a lab in Italy to take a list of curated organic Italian fruits known for their anti-aging quality in the blue zone where people live longer. And we now have a high concentration capsule, a one a day, of only the fruit exosomes. So one of these capsules is like eating, a large container of fruit. It would be difficult to eat that much fruit in a
Yeah.
day. Plus, you get a lot of fructose sugar you probably don't need. So this doesn't replace eating fruit. You still need to eat fruit, but if you're really looking for a simple one capsule a day phytonutrient, then we're very excited about this, and I'll send you a link. You can put it in the show notes if you want.
Yeah,
But
yeah, that'd be
it's
great.
it's called Longevex for exosomes for longevity, and
Okay.
far as I know, it's the only exosome product as a supplement, and it does survive the gastrointestinal tract. It's a hardy membrane, and we get great bioavailability to the cells because it delivers directly to the cell, doesn't get lost in the bloodstream.
That's a once a day type of
Yep.
capsule.
And you can get rid of your resveratrol capsule, your quercetin, your fisetin, your spermidine, your glutathione, your vitamin Bs, except B12, and even vitamin C, because it's all in that exosome at a high concentration with high potency delivery to the cell.
Yeah, nice.
Yeah.
Well, actually, just a follow-up question from that. Obviously, if you're in your poor health and you take something like that and maybe you feel some benefits, what would be some of the things that people would know, yeah, whether it's having a benefit or not?
Well, most supplements you don't feel the benefit, right? You're taking them because you know your cells need them for optimal health. Maybe you sleep a little better, maybe you run a little faster, maybe your brain
Yeah,
works a little better, or you live a little longer. This particular collection of fruit-derived exosomes is really for anti-aging. We selected out anti-aging fruits that are
right.
high in resveratrol, things like that. Um, but the people who have been taking it, the one thing that stands out is many of them say, I feel a little extra energy. So
Yeah.
that's why we recommend you take it in the morning.
Yes. Okay. Yeah, cool. Well, yeah, shoot that link through because I'll add it to the bottom here, and I would love to give it a try myself.
Right.
Jeff, this has been amazing. Thank you so much. It's such an honor to have you on the show. I mean, thank you like globally for the work that you're doing. This is incredible. I have a number of clients that actually I have one client that I just had a conversation with 24 hours ago that their lifespan has been dramatically reduced to perhaps only 10 more years. I have another client that has a severe inoperable brain tumor, and he doesn't know how long he has. A young family and everything. And so I'm going to talk to them specifically about your therapy, but like you're saving lives, you're changing humanity, reducing pain, all that kind of stuff, and it's just really beautiful work. So I want to thank you for everything. Thank you for reaching out, for being on the show. It's an honor to have you here, and I want to give you the closing word. I like to ask my guests that like so successful like yourself, what's the greatest advice that you've ever received?
Well, that I've ever received.
Yeah,
I would say a professor of mine, a favorite professor of mine, said, "Do the right thing," and that's been easy. It's easy. Just do the right thing.
beautiful. Actually, I'm now going to ask you a follow-up question because it is the mental toughness and body show. What's a typical day look like for you in terms of your health and wellness? What do you do to look after yourself?
I'm at the gym at 6 a.m. Some kind of workout, either Pilates or a brief workout. My workout is usually strategic cardio, maybe 20 minutes of intervals, high intensity, low intensity intervals, and then maybe 20 to 30 minutes of heavy lifting, one set to failure. I don't do multiple sets.
Hmm.
I think that's more tradition than it is logic.
Yeah,
And then some always end up with some planks. You got to work
yeah,
that the right abs muscles.
cool. Yeah,
Shower and then to work, and then I meet with patients all day, do procedures, have these great meetings where I meet people like you, and we share this with the world here because this is the tip of the spear for free speech. And
mm,
then I should say I don't eat breakfast. I might have something to drink, and then I'll probably around noon have my first meal, protein heavy. I'm very big on pushing protein. None of us get enough protein. I do
yeah,
take a lot of supplements. Here's a
yeah,
typical day worth of supplements for me.
yeah. Wow.
Now, it used to be a lot more, but now I got rid of 5 or 6 since I started taking Longevix.
Yeah.
Then protein dinner. I try to eat by 6 p.m. And then winding down time. I'm usually doing a little bit of work at home on my laptop or relaxing with family, and then try to get to bed 9:30, so I can get up again at 6 and do it all over again.
What's your de-stressing type of program look like? Because you feel like we know all doctors globally are um, so overworked.
Yeah, I'm blessed in that I can just I can just sit down and turn my brain off, and I can go to sleep, in a few minutes. So I'm blessed in that way. So I don't really need too much of that, but the exercise, even though I do it early in the morning these days, has been probably the biggest contributor to that.
Yeah, yeah, beautiful. Well, thank you so much. I love getting an insight into what people's lifestyles are like. Thanks so
Yeah,
much for being on the show again. It's been awesome having you here. We'll have to reconnect at some point because I mean we could just keep talking for hours. This is just beautiful work.
agreed. I'd love that. Thank you so much for having me.